Welcome back to this series of Power Electronics Labs. Today we will go through the Lab 5, Phase Shift Circuit. The contents are 1. Purpose 2. Circuit and Principle 3. Building Prototype 4. Testing Results. Now let us start with the purpose. The purpose of this lab is to build and test a phase shift circuit for rectifier control. The reference signal is a AC voltage, which is stepped down from a wall outlet. That will be the input of rectifier in the next lab. The output signal will be a phase shift signal for the rectifier control, where the phase shift angle delta will be adjustable. Now let's look at the circuit of the prototype and its working principle. Here is the schematic of the prototype circuit. The prototype includes 5 portions. 1. Digital. 2. Edge detector. 3. Phase shift. 4. Oscillator. 5. Gate signal. The working principle of the circuit can be seen in the diagram of the waveforms of the signals in each portion. 1. Digital part generates 2 half-wave digital signal according to the AC reference signal. 2. Edge detector generates a pulse at every edge of the digital signals. 3. Phase shift generates a delay time delta from each edge. 4. Oscillator generates high-frequency pulses. 5. Gate signal generates 2 gate signals for the rectifier control. Now let's build the prototype. The components used in this lab are the printed circuit board, the circuit built in previous labs, 4 pieces of integrated circuits, and their sockets, a electrolytic capacitor of 1 microfarad, 3 surface mount capacitors of 0.1 microfarads, 9 surface mount resistors, 2 pieces of 1K, 7 pieces of 10K, a potentiometer of 10K. Now let's populate the components onto the PCB step by step. First, solder the surface mount resistors and capacitors. Step 2, solder the 4 IC sockets. Step 3, solder the potentiometer and electrolytic capacitor. Now let's insert the 4 pieces of ICS into their sockets. IC1, AS393, comparator. IC2, 74HC132, NAND gates. IC3, 74HC123, monostable. IC4, 74HC21, and gates. After that, the prototype is completed. Now let's test the prototype and get the results. First, let's check the waveform of the AC reference. Connect the probe of the oscilloscope channel A to the test points AC1 and AC2, a sine waveform is captured. Then check the 2 half-wave signals. Connect channel A to AC1 to ground, and channel B to AC2 to ground. 2 half-wave waveforms are shown here. Now let's keep the channel A as the reference signal, AC1 to ground, and check the other signals with channel B. The digital signals DP and DN are 2 half-wave digital signals referring to the AC reference. Here shows the signal DN relating to the AC reference. The next check is the edge signal. It has a short pulse at every 0 crossing of the AC reference. Here is the phase shift signal. The phase shift angle delta is adjusted by adjusting the value of the potentiometer. Now let's check the oscillator output, which has a frequency of 1 kHz, ready for the pulse transformer in the next lab, rectifier. The next check is the gate signal, which combines the phase shift signal and oscillator signal. Again, adjust the value of the potentiometer to adjust the phase shift angle delta. Now we complete the whole lab. Thanks for watching.